thermal physics, thermal properties of matter, temperature, scales and thermal expansion, name of the scale, symbols for each degree, lower fixed point LFP, upper fixed point UFP, number of division on the scale, Celsius, degree Celsius, 0 degree Celsius, 100 degree Celsius, 100 Fahrenheit, degree F, 32 degree F, 212 degree F, 180 number of division on the scale 180 Kelvin K, lower fixed point 273.15 K, upper fixed point 373.15 K, number of division on the scale 100, C minus 0 upon 100 minus 0 is equal to F minus 32 upon 212 minus 32 is equal to K minus 273.15 upon 373.15 minus 273.15 is equal to X minus LFP upon UFP minus LFP. Del C upon 100 is equal to del F upon 180 is equal to del F upon 100 is equal to del X upon UFP minus LFP. Old thermometry theta minus 0 upon 100 minus 0 is equal to X minus X naught upon X 100 minus X naught. Two fixed point ice and a steam point. Here X is thermometric property, that is length, resistance. Modern thermometry T minus 0 upon 273.16 minus 0 is equal to X upon X TR. Only one reference point, triple point of water. Thermal expansions in solids. In solids, linear expansions L is equal to L naught in bracket 1 plus alpha del T. Before heating, after heating. In solids, aerial expansions A is equal to A naught in bracket 1 plus beta del T. In solid, liquid and gases, volume expansions V is equal to V naught in bracket 1 plus Y del T. For isotropic solids, alpha, beta, gamma is equal to 1:2:3. Thermal expansions of an isotropic object may be imagined as a photographic enlargement. For an anisotropic material, alpha x plus alpha y and y is equal to alpha x plus alpha y plus alpha z. Applications of thermal expansions in solids. Bimetallic stripe used as thermostat or the auto cut in electric heating circuits. R is equal to D upon in bracket alpha minus alpha 2 del T. Room temperature A1 is greater than A2. Higher temperature, simple pendulum. Simple pendulum T is equal to 2 pi in under root L upon G. T directly proportional L 1 upon 2 del T upon T is equal to 1 upon 2 del L upon L. Fractional change in time period del T upon T is equal to 1 upon 2 alpha del theta. A scale reading due to linear expansions, contractions, a scale reading will be lesser more than actual value. If temperature increase then the actual value, a scale reading in bracket 1 plus alpha del theta. Thermal stress, thermal strain del L upon L is equal to alpha del theta as Young's modulus y is equal to F upon A del L upon L. So thermal stress Ya alpha del theta is equal to Ya alpha del theta upon 1 plus alpha del theta 1 plus alpha. So thermal stress Ya alpha del theta is equal to Ya alpha del theta upon in bracket 1 plus alpha del theta. Thermal expansion in liquid. Thermal expansions in liquids only volume expansions. Ya apparent increases in volume, initial volume into temperature rise. Yr real increases in volume, initial volume into temperature rise. Yr is equal to Ya plus Y vessels change in volume of liquid with respect to vessels del V is equal to V naught in bracket R in bracket gamma R minus 3 alpha del T. Expansions in enclosed volume V naught initially finally alpha vessels YL liquid increases in height of liquid level in tube when bulb was initially completely filled. H is equal to apparent change in volume of liquid area of tube V naught in bracket YL minus alpha 3 alpha del T upon A naught in bracket 1 plus 2 alpha del T. Anomalous expansions of water in a range theta 0 degree Celsius to 4 degree Celsius. Water contract on heating and expands on cooling. At 4 degree Celsius density is maximum. Aquatic life is able to survive in very cold countries as the lake bottom remains unfrozen at the temperature around 4 degrees Celsius. Thermal expansions of gases, coefficient of volume expansions YV is equal to del V upon V naught del T is equal to 1 upon T. PV is equal to nRT at constant pressure alpha V directly proportional T is equal to del V upon V is equal to del T upon T. Coefficient of pressure expansions Yp is equal to del P upon P naught del T is equal to 1 upon T. Important point: liquid usually expand more than a solid because the intermolecular forces in liquid are weaker than in solids. Rubber contract on heating because in rubber as temperature increases the amplitude of transverse vibration increases more than the amplitude of longitudinal vibrations. Water expands both when heated or cooled from 4 degrees Celsius because volume of water at 4 degrees Celsius is minimum. In cold countries, water pipe sometimes burst because water expands on freezing because water expands on freezing,